This lesson is for Unit 2, Lesson 4, Square Roots, Part 1. So in this lesson, we're going to be talking about multiplying square roots. And for square roots, the product is equal to the product of the square roots. So underneath the radical sign here, you can have the two numbers multiplied by each other, or it's the same as multiplying a square root of a number times the square root of a number. So in this case, we could evaluate them separately, finding the square root of 16 being 4 and the square root of 25 equaling 5, and then know that the answer is 20. But we can also multiply so that we are looking at the square root of 16 times the square root of 25, which is equal to the square root of 400, and then take the square root of that number, which comes out to be 20. In the other example, since these two are not perfect square roots, square root of 8 is not going to be a perfect square root, and square root of 6 isn't a perfect square root. You can just multiply the two factors underneath the radical sign, so 8 times 6, to have an answer of the square root of 48. So square roots work where you can just multiply the numbers underneath the radicals to simplify where needed. You can also use this property in reverse. So if we have the square root of 12, you could think of this as being the square root of 3 times the square root of 4. Or you could think of it as the square root of 2 times the square root of 6. Or another method, square root of 12 times the square root of 1. Just what your goal is when you're breaking that number apart is you're trying to find groupings of perfect squares. So in this grouping here, square root of 3 times the square root of 4, the square root of 4 is a perfect square. I know that the square root of 4 is 2, and then this is the square root of 3. So square root of 3 times 2, my answer would simplify to be 2 times the square root of 3. So just know that you can break those numbers apart as factors in that same way. Dividing square roots, you can have dividing where you either divide the entire fraction underneath one radical, or you can divide where you break it apart so that you have the square root of the top number over the square root of the bottom number. And just depending on what those numbers are, it'll be easier to separate it out or divide it all as one. This first one, square root of 1/9, if I were to rewrite this as the square root of 1 over the square root of 9, this would simplify easily because 9 is a perfect square. Square root of 9 comes out to be 3. So then we have the square root of 1 over 3. And this is an acceptable answer. With square roots and with fractions, you don't want a square root as part of your denominator. This other one, 16 over 81, you could reduce this fraction first, otherwise separating it out. I'm noticing that 16 is a perfect square and 81 is a perfect square. So if we were to instead write this as the square root of 16 over the square root of 81, I can find the square root of 16, which is 4, and then the square root of 81 is 9, so I know that my answer would be reduced down to 4/9. Just a couple of challenge questions with division. This first one would be an example. Neither of these are perfect squares, but if I rewrote this as 12/3, 12 divided by 3 is 4. This would simplify to the square root of 4, and that's a perfect square. So we can say that the square root of 4 then is 2. It's a lot easier in this particular example to divide out 12 divided by 3 instead. For this other example, if we rewrote this one as dividing with one fraction, so 20 over 45, this fraction actually has numbers in common where we could reduce it. If we divided both the numerator and the denominator by 5, I would end up with the square root of 4 over 9. And then this, If you break it back the other way, square root of 4 over the square root of 9 comes out evenly because they're both perfect squares, so you end up with 2/3. And you could have actually divided out the common factor from the other one. It's just easier to see that it's a fraction that you're looking at when you have the square root of the entire fraction. Next part with evaluating square roots, you can think of this as being 2 times the square root of 9 plus 3 times the square root of 4. So 2 times the square root of 9 is 3, plus 3 times the square root of 16 is 4, and then you're just simplifying using order of operations. So 2 times 3 is 6, 3 times 4 is 12. You end up with an answer of 18. And then one more example, 4 times the square root of 4. Remember when it's written like this, 4 times the square root of 4, which is 2. Plus 7. Now this one, the square root of 36, this isn't a perfect square, but remember when you multiply, you can break it apart into factors. If I think of what perfect factors or perfect square factors I have, you could think of the square root of 36 as being multiplying by the square root of 4 times the square root of 9, and those are both perfect squares. So 4 times 2 is 8, plus 7 times square root of 4 is 2, times the square root of square root of 9 is 3. And then we have 8 plus 14 times 3, and 14 times 3 simplifies to 42. So we're adding 8 plus 42 to get to 50.